All right, guys. So today we're going to learn some rules for right angle rotations on the coordinate plane. Okay, continuing our series of rules for transformations on the coordinate plane. If we just look at the coordinate plane and we think about rotations around the origin to keep things simple, if I rotate this figure at some angle that's not a right angle, then the math is going to get really tricky. So let me come back. Notice the special situation when I rotate it 90 degrees. When I rotate it 90 degrees, our coordinate plane looks very similar. The big difference is that now our x is vertical and our y is horizontal. Our x and our y's switch places. And if you remember from our reflections over y equals x, that means that we're doing an inverse, right? We're switching our x and our y. Keep that in mind as we do our rules. Okay, let's look at a specific example.
All right, so I have a trapezoid and I'm going to put a, this point is at 1, 2, 3, 4, 1, 2, 3, 4, 5. So at -4 and 5. So we're going to look first just at this specific point, rotated about the origin. To think of it as a right triangle. So I'm going to draw this, draw a right triangle here. Because when we draw a right triangle, then the legs will be our coordinate, right? So it's the x goes to the left 4, and the y is positive up 5. And we could put an arc and find the 90 degrees by using our protractor, for example. What I'm going to actually do is I've made a little copy of our trapezoid here. When I rotate this 90 degrees clockwise, right, it's going to end up right here like that. And you can see that literally the trapezoid turns on its side, right? So you can see it's over 1, 2, 3, 4, 5 and up 1, 2, 3, 4. So this would be the point right there, which is on our arc. It's a 90-degree clockwise rotation about the origin. Okay, now I'm going to also draw a triangle for this point. Notice to get to the same point on the triangle, the corresponding point, I go over 1, 2, 3, 4, 5, and I go up 1, 2, 3, 4. Okay, so this point would be at 5, 4. You can see that my y value, 5, has now become my x value, and my x value, -4, has become my y value, but it is the opposite. Okay, and right there is our rule that our x, y maps to our y, which was 5, just moves to become our x value. So let's put that y as our x value. And what does our x value do? It becomes our y value and it takes the opposite value. So y opposite x. Okay, so there's our rule for a 90-degree clockwise rotation about the origin. Our xy becomes y opposite x. All right, and we could do the same thing with each of the points. So we could also take the same diagram and we could write a rule for a 90-degree counterclockwise rotation about the origin, right? Okay, so if we were going to do a counterclockwise rotation, we could have this figure be our pre-image and this figure be our image, and we just change the direction of rotation, right? In other words, a counterclockwise rotation of 90 degrees is just simply the inverse of a 90-degree clockwise rotation, right? That said, if we take 5, 4 to be our original x, y, then what's going to happen? Our y value, 4, is going to become our x value, and it's going to be the opposite. So we would say opposite y, and then our x value is simply going to become our y value, no change in sign. So x would go second. Okay, so notice our rules are very similar. We have x, y become mapping to y opposite x in a clockwise rotation, And in the counterclockwise rotation, we have x, y mapping to opposite y, x. All we need to do is remember two things. We need to know that the x and the y switch position, and we need to know the signs of each of the quadrants of our coordinate plane, right?
So just in the first quadrant, it's always going to be positive, positive. Second quadrant is always going to be negative, positive. Third quadrant, negative, negative. And fourth quadrant, positive, negative.
All right, let's try out a problem. So we have triangle ABC, and we're going to complete a 90-degree rotation counterclockwise.
Opposite direction of a clock, also known as a positive rotation, in the same order as we number our quadrants, 1, 2, 3, 4. I picked this problem because we have point A, the vertex A is in the second quadrant, the vertex B is on the quadrantal, and the vertex C is in the first quadrant.
If we rotate our paper 90 degrees counterclockwise, we can see exactly where our image is going to end up, right? Okay, so let's now start with point A, and we're going to find point A prime.
1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So we can see that A is at 4, or I'm sorry, negative 4, 7, right? Left 4, up 7. Okay, to find A prime, remember we're going to switch these. So I'm going to show you how I like to do it. I just go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. And then I know my A prime is going to be in the third quadrant. So I'm going to go back 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, right? And so this will be my A prime. Okay, notice that I went 7, 4, it's third quadrant, so I know they're both negative. So negative 7, negative 4. All right, so again, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Very easy. All right, now point B is on the quadrantal, right? So that's actually at what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's at 0, 9. Okay, so we know these are going to switch around, but think about where it's going to rotate. I'm going counterclockwise, so it's going to be on the negative x-axis. So it's going to be
1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
So B prime is at negative 9, 0. Right, again, I've just switched the x and the y. Okay, now C is in the first quadrant, which means that when I rotate at 90, it's going to end up in negative positive. We can see it's at 1, 1, 2, 3, 4, 5, right? So 1, 5. So we're going to go 5 and 1 over here, right? So 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. And that's where we'll find our C prime. And it will be at, switch these, negative 5, positive 1. Right?
Again, if you just remember that this is positive, positive, negative, positive, negative, negative, and positive, negative, then you will easily find the signs. Last thing left to do is just connect my points. So I have my pre-image and I have my image. Again, notice that I can get a visual on that. I can also take my, pick a point. Let's take point C. And if I connect this line to the origin, right, I can see that that was a 90-degree rotation. If I want to use my compass, I can show exactly where that point traveled, so to speak, right? And the direction was this way, so I can put an arrow on that, and that's my 90-degree rotation counterclockwise around the origin. All right, so a quick review. When we're doing 90-degree rotations, whether it's clockwise or whether it's counterclockwise, our x's and y's switch positions, right? So it's a type of an inverse, okay? There's also something that goes on with the signs, right? If it's counterclockwise, the y takes the opposite value, and if it's clockwise, the x takes the opposite value. But you don't have to remember that. Better to just remember is in the first quadrant and you're going clockwise, then you'll end up in the fourth quadrant, right? If you're in the third quadrant and you're going counterclockwise, you're going to end up in the fourth quadrant. So just think about which quadrant your point will end up in, and then that should let you know what the sign should be so you don't make a mistake there. All right, and you can also count just like you're using a triangle. So if I'm going from this point counterclockwise, I'm going 4, 5, 4, 5 to get to the point. All right, I hope that was helpful. And if you have any questions or concerns on the problems that I send you, bring them to class tomorrow.
Remember,
I see math in everything.